14.5 A. State that all electromagnetic waves travel with the same speed in free space, and recall the orders of magnitude of the wavelengths of the principal radiations, from radio waves to gamma rays. Question 1. Who showed that all electromagnetic waves travel with the same speed in free space? And what's the value of the speed? Question 2. What happens to the speed, frequency, and wavelength of light when it travels from a vacuum into a material medium? Question 3. List the orders of magnitude of the wavelengths of these principal radiations. So the answer for question 1, James Clerk Maxwell showed that the speed of electromagnetic radiation in a vacuum was independent of the frequency of the waves. In other words, all types of electromagnetic wave travel at the same speed in a vacuum. And he is one of the greatest physicists of all time. He set up the theory of electromagnetism, which suggests that light is also an electromagnetic wave. So the speed of electromagnetic wave in free space is the speed of light in free space, which is this value. It's a very long, very big number, and hard to memorize. But the approximate value is simple, which is 3.0 10 to the 8th meters per second. And this value is what we should memorize. And now let's move on to the second question. What happens to the speed, frequency, and wavelength of light when it travels from a vacuum into a material medium? The first thing we are sure is the frequency remains the same, because the frequency of a wave is determined by its source. And the second thing we figure out is the speed of light changes, because the speed of a wave is determined by the medium. Actually, the speed of light decreases when it travels from a vacuum into a material medium, because the speed of light in a vacuum is the maximum speed. Hence, the wavelength of light, which is equal to the speed of light divided by the frequency of the light, decreases too. What we have just talked about is for light, but actually it works for all electromagnetic waves. So now we know the wavelength of an electromagnetic wave changes from one medium to another. So what we can learn from this fact is that we often think of different forms of electromagnetic radiation as being characterized by their different wavelengths. But it is better to think of their different frequencies as being their fundamental characteristic. Now we are going to look at the last question. The orders of magnitude of the wavelength of the principal electromagnetic waves in a vacuum are listed in this table. In the first column is the length of the radiation, while in the second column is the wavelength range. From the top to the bottom, the wavelengths decrease. As you can see, there are many radiations with different values of wavelength, so it's hard to memorize, but you must try. And my way to memorize this is, first I memorize the sequence of the radiations from long wavelength to short wavelength. And what we are most familiar with is the visible, before which is the infrared, and after which is the ultraviolet. And we know that electromagnetic radiation with longer wavelength has smaller frequency and thus have smaller energy, so it affects our health less, or we can say it's more health friendly. So the electromagnetic radiations with smaller wavelengths are used more often and more widely in our daily life. And that's one of the reasons why radio waves are used for communication almost everywhere in our daily life. And why the microwaves are used in microwave ovens in our kitchen rooms. And that's also the reason why we shouldn't be cautious to take X-ray scan, as the X-rays with such small wavelengths can be harmful for our health. And if you are pregnant, you will not be allowed to take X-ray scan for the protection of the baby. And the gamma rays, we know they are often produced in nuclear reaction, which releases huge amount of energy. So that's how you memorize the sequence of the radiations from large wavelength to small wavelength. Then you memorize the corresponding wavelength range, and there is no shortcut. Just memorize them directly. One funny fact you may notice is the visible radiation, what we human beings can see, lie in a relatively small wavelength range.